After all these decades of delays and vagaries and frustrations, Mars is finally in our sights. Officially, we have a date. 2040 as laid out by the National Aeronautics and Space Administration. Granted, this date is nowhere near as aggressive as what Elon Musk is putting out, but at the same time, NASA intends to spend considerably more than Elon Musk's $100 billion wealth on achieving this goal. Their budget is going to be increasing, assuming Congress agrees to all of this, radically year by year until we ultimately achieve a Mars landing by 2040 and multiple landings on the moon by 2030. Does all of this sound too good to be true? Well, yeah, it kinda does to me as well. But think of the possibilities. Within my lifetime, hopefully, I will be able to finally see mankind set foot on the surface of another planet, and not just any planet, a planet with volcanoes far more mammoth than any mountain that we have on Earth, and canyons far more vast and far deeper than anything on Earth. Many, many wonders that are simply unrivaled throughout the solar system, and if I live past my 80s, I may actually live to see a permanent base established on the red planet. But how is all of this going to be possible? How the hell is NASA, who has taken so long just to get the SLS completed and get Artemis 1 off the ground, and by the way, it's not off the ground yet, how are they really going to go from Artemis 1 to Mars in 17 years? Well, the bad news is that the big orange rocket is most definitely going to play an important part of this mission, at least at the outset, because the first 4 SLS rockets have essentially been bought and paid for. And not only that, billions of dollars of future NASA appropriations are also earmarked for SLS. So this rocket, as inefficient and non-reusable as it is probably going to play an important part, at least, of the Artemis mission. But to get all the way to Mars, SLS and Orion is simply not going to be able to fit the bill. We're going to need something else. We're going to need something bigger, and perhaps something faster as well. Perhaps something along the lines of Starship, and perhaps something along the lines of a nuclear Starship. And we're gonna find all of this out in just a moment. Sometime in May of this year, assuming all goes well, and that is a thing that I really don't have a great deal of confidence in given all of the delays that we've had thus far, but let's assume that it is indeed in May, the entire process of Moon to Mars will begin. Artemis 1 will push out to the launch pad, having completed all of its tests, and prepare for its journey to the Moon. But this, of course, will only be the first step. This rocket will simply orbit the moon, deploy a number of small sats, and test out the entire orbit configuration and the configuration of the mission in general. And Orion will then come back and splash down, hopefully successfully, without any issues whatsoever. If this all goes according to plan, then Artemis 2 will be next on the docket. And that is scheduled to take off in 2024. Now, in the meantime, NASA, if everything gets approved by Congress, is going to have significant increases to its budget. $26 billion in fiscal year 2023, $26.5 billion in 2024, $27 billion in 2025, $27.6 billion in 2026, and finally $28.1 billion in 2027. And we can expect there to be more increases after that before the final scheduled Artemis mission in 2030. But the critical difference about the 2023 budget and beyond is the fact that more money is being spent on Artemis. $4.668 billion to support the SLS and also the Orion, not something I'm terribly thrilled about, but nevertheless, it continues to support the primary rocket that's going to be used for human transport, and on top of that, nearly $1.5 billion for HLS, by far the largest amount of money that's been allocated for the human landing system, and something that is absolutely vital if we really plan to land on the moon by 2025 or 2026. On top of that, $779 million for the Gateway, which is a very nice thing, $60 million for cislunar and surface capabilities, and $276 million for spacesuits and surface mobility. On top of that, $161 million will already be spent for the Mars campaign development, which means we're already spending money on going to Mars. $121 million for habitation systems and $26 million for human support and enabling capabilities. I like the idea that we're spending over $100 million on habitation because we're going to need it, since a Mars mission will probably be staying on the red planet for nearly 2 years. But one thing that I find to be particularly interesting is the fact that $45 million is being allocated towards space nuclear power and space propulsion. Granted, this isn't a tremendous amount of money, but this isn't the only money that the government is spending on space nuclear propulsion, not even close, and we're going to get to that a little bit later. So back to Artemis and the overall plan for getting us to the moon before we go to Mars. Now, one thing that I find to be particularly gratifying is the fact that the Gateway is now where it should be. That is to say, right after Artemis 2. We aren't going to be trying, at least according to the latest plans from NASA, and the links for this plan are in the description. The Artemis 3 mission is not going to attempt to dock directly with the Orion capsule, at least from what I can see at the moment. Instead, we are going to deploy the power and propulsion element and habitation and logistics module, of the Lunar Gateway before we attempt to send out Artemis 3. Now, keep in mind, the first two components of the Gateway do not depend on an SLS launch. These are going to be deployed by a Falcon Heavy and can be deployed pretty much at will. And given how long it's going to take for Artemis 3 to be ready, I suspect that we are going to have the Gateway in place in time. Now, as strange as this may sound, my biggest concern about Artemis 3 is the SpaceX Lunar Starship component of the mission, simply because the first uncrewed demonstration of the Lunar Starship is scheduled for 2024, 2 years from now. Lunar Starship must have already gone to orbit, must have already mastered the whole LEO refueling process, and must be ready to land on the lunar surface, not with the crew, but land successfully and then return to orbit and return to LEO. All of this must be accomplished by Lunar Starship in 2024, a mere 2 years from now. That's something that I think is going to be incredibly challenging. And not only that, Lunar Starship must then be ready to carry a crew from the Lunar Gateway down to the lunar surface by 2025 for Artemis 3. Now, it's entirely possible that this whole thing is going to get delayed until 2026 anyway, and NASA has built that into their timeline because Artemis 4 is not scheduled to go until 2027. And herein lies one of the most disappointing aspects of the whole Artemis mission, is the fact that we will not be going back to the moon for another landing until 2028. Artemis 4 is scheduled not to land on the moon, but instead to deliver the IHAB, which is largely being constructed by the European Space Agency. This is a very, very large space station component designed for long-duration lunar stays. Since it is so large, it's too big for any commercial rocket, including Falcon Heavy. Only SLS or Starship, assuming that it was ready to carry something like this, is going to be able to transport the IHAB all the way to cislunar space, which means 2027, and Artemis 4 is simply going to have the rather disappointing mission of delivering another component of the Lunar Gateway. Now, will it also be able to deliver a crew? Well, probably not, because this is going to be a cargo version of the SLS, the SLS Block 1B. However, it's in 2028, the year that NASA was originally planning to go to the moon anyway, that things really start to take off with Artemis 5. We have another human landing on the moon, perhaps utilizing the Lunar Starship, or perhaps using an alternative depending on how the Starship performed with Artemis 3. And by that time, there will be a competitor, and I hope that it's the Dynetics Alpaca, which can be used in conjunction with the Lunar Starship in a video that I put out not that long ago, linked in the description. But on top of that, we are also going to have an ambitious lunar rover, or lunar cruiser if you wish to call it that, and this is one example of a variety of different designs that are coming out to transport astronauts extensively across the lunar surface. This particular vehicle is powered by hydrogen, which means it doesn't require nuclear power, nor does it require solar power. It can run off of power that can be found on the moon in abundance, simply because water ice is on the south pole of the moon in abundance, therefore hydrogen is present in abundance. Not only that, there's also water ice across the lunar surface, as we have recently discovered, and to power something like this, we wouldn't need a tremendous amount of water ice or hydrogen, and this thing has an effective range of 10,000 kilometers, allowing astronauts to travel extensively across the lunar surface. And there are a variety of other designs as well, far more compact, although not pressurized. And in my opinion, a pressurized lunar vehicle is going to be an absolute essential. And although it makes obvious sense to utilize Lunar Starship for Artemis 5 simply because it can carry so much mass, including, of course, a lunar rover, it's important to note that the modular Dynetics Alpaca can also carry a lunar rover slung underneath the vehicle, just as the crew module can be slung underneath it. And it can also be used for lunar habitats, as you can see here, inflatable habitats as could be provided by Sierra Space. So this particular lander has a great number of different missions that it could undertake, certainly not with a tremendous amount of mass that Starship is capable of carrying, but with a lot more flexibility in terms of the amount of fuel it would require to deploy it, and also the logistics in terms of getting the ship to the moon in the first place. The Alpaca could land on the moon, go back to cislunar space, refuel with a tanker, hopefully the lunar Starship, and land again in the same mission, something that lunar Starship is incapable of doing. Nevertheless, no matter which lander we use, 2028 is going to be very exciting indeed, and we are going to be building up our deep space logistics at the same time in preparation for going to Mars. During this time, the ESA Esprit module, which is for communications and refueling on the Gateway, will be delivered, and in the following year, an airlock, which originally was supposed to be constructed by Roscosmos. We're not sure who's going to be building that now, but that also will be delivered to the Gateway. Also, of course, we're going to have back-to-back human missions landing on the moon from then on out. 2028, 2029, 2030, and I lied, there's going to be another one in 2031. Each additional mission will have longer duration stays and more ambitious things being placed on the surface of the moon. For example, long-term habitats, more ambitious rovers, and also nuclear power for the surface habitats. This is something that is absolutely vital for long-term survival on the moon, simply because solar power doesn't work half the time because the moon is perpetually shaded for 14 days out of every 28. But here's what's important about all of these missions and why they are absolutely vital to our future on Mars. All of these things are going to work, and work better actually, on the red planet than they're going to work on the moon. Any sort of habitat that allows us to survive on the moon, which becomes far, far colder than any Martian night, is going to work obviously on Mars. Any nuclear power source that works on the moon is going to work on Mars. Any rover that works on the moon is going to work on Mars. Any EVA suit, well, there may be some limitations with that because Mars has twice the gravity that the moon does. So any sort of Martian EVA suit may require modifications in order to be effective, but nevertheless, that's going to be applicable to Mars as well. And during this time, larger amounts of money are going to be allocated towards Mars exploration. $121 million, for example, in 2023 to continue developing and testing capabilities required for deep space missions, including radiation protection, spacecraft fire safety, logistics reduction, with a focus of evolving the next generation of environmental control and life support systems. Also, money allocated for human support and enabling capabilities to develop countermeasures such as exercise equipment to maintain crew fitness, because they're going to be in a reduced gravity environment for a substantial amount of time. And also money to continue building on the current commercial engagement contracts to advance commercial habitation, avionics, flight software, life support, in-space refueling capabilities. That's a big one, and other commercial space technologies. But perhaps the most important skill that we are going to develop while we're working on the moon is going to be ice mining, simply because this is going to provide us with the necessary fuel to go to Mars and to go to Mars quickly. Yes, you can use water ice in order to power conventional rockets like the SLS using liquid hydrogen and liquid oxygen. However, you can also power a nuclear thermal engine using simply liquid hydrogen as a fuel source and utilizing the nuclear reactor to superheat the hydrogen gas and drive it out the nozzle at a substantially higher speed than the speed of the exhaust of a traditional rocket. This increases the efficiency of the rocket by at least double and perhaps triple, something I've talked about many many times, and we intend to have a prototype nuclear thermal engine deployed by the middle of this decade and a fully functional nuclear thermal engine by the end of this decade. This is no coincidence. It is obvious that NASA intends to use this type of propulsion to get us to Mars within a 3-month time frame instead of a 6-month time frame, which has all sorts of advantages, reducing the amount of time that the astronauts have to be in microgravity, reducing the amount of time that they need to be exposed to intense radiation, and reducing the chance of them being exposed to a powerful solar flare. So many advantages to going this fast. And also in terms of transporting cargo, you can transport double the cargo in 6 months that you can with conventional rockets. So there would be many advantages to using this type of propulsion, and NASA is not the only one spending money on this. The U.S. Space Force is allocating a substantial amount of money to nuclear thermal propulsion as well. It is my firm belief that NASA intends to have fully functional nuclear thermal propulsion available by 2040 by the time we make our journey to Mars. And as you can see here, not only will the nuclear power be used for propulsion, but also for power on the Martian surface, therefore not being vulnerable to dust storms which block out solar energy. So many advantages to using nuclear power during our journey and settlements on Mars, and something that NASA is already setting out to do in their budget for 2023. We are seriously moving forward with this process. Now, can we use nuclear thermal propulsion on a Starship? Well, not the way it's currently designed, but there's no reason why we couldn't attach a modular nuclear engine, a nuclear tug, so to speak, to a Starship once it's deployed. Or if we decide to use a different type of ship to get us out to Mars, for example, the Mars base camp as you're looking at right now, then the Starship will certainly be invaluable in constructing something like that. However, I thoroughly believe that NASA, now I'm not talking about SpaceX, but NASA doesn't intend to use Starship for the entire journey simply because of what I like to call the SpaceX Starship suicide dive. The prospect of trying to land something this huge and this heavy on the surface of Mars with such a thin atmosphere is going to be a very difficult prospect indeed. Instead, if you use nuclear thermal propulsion, you will have sufficient propellant left over to decelerate and enter Martian orbit, and then use some kind of a lander to set down on the red planet surface. But here's why ice mining is so damned important. It's not just the factor of whether or not you're going to be using a Starship or any other type of vehicle. You are going to need to carry out LEO refueling of some kind in order to be able to efficiently get a large amount of mass all the way to Mars. Now, the easiest way to do this is to transition the fuel from the moon rather than from Earth. And all this may seem kind of counterintuitive. How do you get fuel from the moon all the way to LEO, which is hundreds of thousands of kilometers, as opposed to a few hundred kilometers up into orbit? Well, it's simply because of the prison of the Earth's gravity. Only 1/6 of the Earth's gravity is what you'll be fighting if you transport fuel from the moon, as opposed to full Earth gravity, and the delta V required to transport fuel from the moon and refuel something in LEO is going to be substantially less. It will be much easier once we have ice mining established on the moon in order to refuel a vehicle in LEO than and sending up vessels from the Earth, as strange as that may sound. And if you're using nuclear thermal propulsion, the only type of fuel you need is hydrogen, and that's available in abundance on the lunar surface. You don't need methane, and methane is not available on the moon, which again leads me to believe that nuclear thermal propulsion is what we're going to be needing. All you need is the hydrogen and, of course, nuclear fuel, but you don't need a great deal of uranium or plutonium or whatever you want to use for the nuclear reactor in order to make the whole thing work. In my opinion, this is NASA's long-term plan. Whether it uses Starship or something else like the Mars base camp that you're looking at right now, nuclear propulsion is the future. Moon to Mars is enabled by nuclear propulsion, and it is much easier to get this entire process going if you use a Moon to Mars approach. But if all goes well, by 2040, we will have established an ice mining industry on the moon for 10 years, therefore making the whole idea of refueling from the moon to LEO a much easier prospect. We will have established an infrastructure from cislunar space to LEO that will have existed for at least a decade. We will have experience in surviving in extreme conditions, far more extreme and far more hostile than Mars presents to us, and we will have the skills, the technology, and the vessels necessary to propel us to the red planet and explore another world for the first time. Hopefully that's the way things go, or perhaps SpaceX can do it faster, but regardless of whether they do or not, I have no doubt that Starship will be involved. If you like what I have to say, if you enjoy this content, please check out the description and contribute to this channel if you can, or simply like and subscribe, and I will be very happy. So until 2040 arrives and we are actually stepping foot on the surface of another planet for the first time, God willing, I urge all of you to stay angry about space.